Today we're going to talk more about ratios and proportions. The first thing we need to decide is what it means to divide sides proportionally. So you'll notice I have figures that are drawn over here on the right to accompany this narration. So consider the triangle ABC here and trapezoid PQRS here, in which the line PQ here is parallel to RS. So this is a trapezoid. These are my bases. We're going to let D be a point between A and B here, and E be a point between A and C over here. Further, we're going to let U be a point between P and S here, and we're going to let V be a point between Q and R over here. Then the line DE divides the sides of AB and AC proportionally. This line divides these two sides proportionally if and only if the ordered pair AD, comma DB, AD, DB is proportional to the ordered pair AE, EC, meaning each of these corresponding parts are in the same ratio. And the line UV divides the legs PS and QR proportionally if and only if the ordered pair PU, comma US is proportional to QV, VR. So PU, US proportional to QV, VR. And again, corresponding parts are in the same ratio. Now that we know what it means to divide sides proportionally, I'm going to introduce a theorem called the triangle proportionality theorem, which basically says that if I have a segment that's parallel to any side of my triangle, it divides the sides proportionally. Now let's read the more detailed description. Consider the triangle ABC. We're going to let D be a point between A and B, and E be a point between A and C, as I've shown over here. Then the line DE divides the sides AB and AC proportionally if and only if DE is parallel to BC. You notice I have it marked that way. Furthermore, when the division is proportional, then DE over BC equals AD over AB. DE over BC equals AD over AB. Next, we're going to prove the triangle proportionality theorem, and I'm doing this in two parts. The first part is going to go through to the word conversely, so I only want you to do up till you see the word conversely that follows directly after this paragraph. So press pause, work on it, and when you're ready for the answer and an explanation, press play again. So you'll notice that I copied the figure triangle ABC down over here so that I could have a diagram to read along with. We're going to let triangle ABC, D, and E be as described in the statement of the theorem. Suppose that the line DE divides the sides AB and AC proportionally. Then I know that AD, DB, the ordered pair, is proportional to the ordered pair AE, EC. So up over here, I just gave you a visual of what these ratios would look like. That means that I could take AD and divide by DB, and that would equal AE divided by EC. Whenever I'm setting up ratios looking at a triangle, I really just follow a pattern. So you'll notice that I have AD divided by DB. Here's AD, top right divided by lower right. That's going to equal AE, top left, divided by lower left, EC. Now by PR2, it follows that my cross products are equal. You'll see AD times AEC equals DB times AE. Let's next examine the product AD times AC. We know that's equal to AD times the quantity AE plus EC, because E is between A and C. So that's just adding up the pieces of a segment. The sum has to be the same as AC. Now, by the distributive property, I can distribute AD into that sum to get me here. And then by the community property and also 1, I switch the order here because multiplication is commutative, and then I substitute AD times EC. I put in DB times AE. Then I factor out the AE, and I make a further substitution for AD plus DB. That's the same as AB because D is between A and B. Hence, by PR 1 and 2, I know that AD over AB equals AE over AC. I would get this by, if I were to cross multiply here, it would land me right back at the equal products. So now we're going to let AD over AB be equal to R. Since D is between A and B, that means that AD must be bigger than 0 and AB must be bigger than AD. So you can see over here, AB has to be bigger than AD. Hence, R is between 0 and 1. It's not 0 and it's also not 1. Furthermore, the magnification of B with center A, is equal to D. Since AE over AC also equals R, we have that the magnification of C with center A is E. So I'm magnifying C, it lands me back at E. It follows from M2 that DE must be parallel to BC because these are images under magnifications. Remember, if I have a segment and I magnify that segment, the result is parallel to its pre-image. And DE then must be equal to R times BC. That is, DE equals AD over AB times BC. AD over AB was the scale factor R. Hence, DE over BC is equal to AD over AB. I get there by dividing both sides by BC. Now I would like for you to finish the triangle proportionality theorem from the word conversely. Press pause on your video, and when you're ready for the answers and an explanation, press play again. So now conversely, we're going to suppose first that DE is parallel to BC. Then we're going to let R be equal to AD over AB. AD over AB. As in the first part of this proof, R is between 0 and 1, excluding 0 and excluding 1. Then the magnification of B is equal to D. Magnifying B, it's landing at D. We're going to let X be equal to the magnification of C with center A. So X is going to be somewhere over here, and in fact it's going to be E, but we're going to prove that. Then X is an element of the magnification of line BC. So if I'm magnifying line BC, X is going to be an element of that because X is the image of C. So, and since R is an element of the numbers between 0 and 1, excluding 0 and 1, I know that X has to be an element of segment AC, excluding the endpoints. So I know that X is somewhere between A and C. Now we also know the magnification of line BC has to be parallel to line BC by M2, and D is an element of the magnification of line BC, because D is the image of B. Since by PP there is only one line through D that is parallel to BC, and since we've assumed that DE is such a line, it follows that X is an element of DE. Since the line AB is not parallel to line BC, we have that AC is not parallel to DE. Thus, AC intersects DE in a single point. But we now know that X and E are elements of AC, and X and E are elements of DE. Consequently, X equals E, and AE equals R times AC. That's the definition of magnification. That is, AE equals AD over AB times AC. This is by substitution. Remember, we let this be R. Hence, D is between A and B, and E is between A and C. And following up from over here, we can multiply both sides of the equation by AB, and that gets me here. AE times AB equals AD times AC, and then we substitute in AD plus DB is really AB, because D is between A and B, equals AD times the quantity AE plus EC, because E is between A and C. And then we distribute the AE in, and we also distribute the AD in, and that gets me here. And then, now if we divide both sides by the product of AE times AD, we obtain AE times DB equals AD times EC. And just for fun, I took this and wrote this in a ratio format. So I know that AD over AE is equal to DB over EC. If I were to cross multiply here, I would end up with this product. Now, by commutativity in PR2, we see that AD comma DB, the ordered pair, is proportional to AE comma EC. It follows that DE divides the sides AB and AC proportionally. Here's a corollary to the triangle proportionality theorem. So first you need to know what a triangle midsegment is. A midsegment is a segment that joins the midpoints of two of the sides of my triangle. So this would be a midsegment. The triangle midsegment theorem says that if it is a midsegment, then that midsegment's parallel to the opposite side. It also says that it divides these sides proportionally. More specifically, we're going to consider the triangle ABC. Let's fill in some letters here, A, B, C, and we're going to let D be the midpoint of AB, and we're going to let E be the midpoint of AC. Then we know that DE, the line DE, is parallel to the line BC, and the segment length of DE is 1/2 the segment length of BC. This is the trapezoidal proportionality theorem. The proof is in exercise 178, and I'm going to install the model answers so that you can read it as part of your homework tonight. You're going to consider the trapezoid PQRS, I have it drawn over here, in which the line PQ is parallel to the line RS. We're going to let U be a point between P and S here, and V be a point between Q and R over here. Then the line UV divides the legs PS and QR proportionally if and only if line UV is parallel to line PQ. Furthermore, when the division is proportional, then I know that UV is equal to SU over SP times PQ plus 1 minus SU over SP times RS. And just to make it a little bit more clear, I put in some single letters to represent the legs, the pieces of the legs. So I know that my midsegment UV is equal to A over the sum of A and B times the base PQ plus 1 minus A over the whole length of SP, A plus B, times the base SR. And then one more thing, I want to put another parallel mark there because those are my bases. And further, the legs divide this segment divides the legs proportionally. So A over B equals D over C. A corollary to the trapezoid proportionality theorem has to do with the trapezoid midsegment. So the midsegment of a trapezoid relative to the base of the trapezoid is the segment whose endpoints are the midpoints of the legs of the trapezoid relative to that base. You can see I have it drawn over here. So UV is a midsegment of this trapezoid. So we're going to consider the trapezoid PQRS, in which PQ is parallel to RS. We're going to let U be the midpoint of PS and V be the midpoint of QR. Then we know that UV is parallel to PQ And we also know that the length of the midsegment is half the sum of the bases. Now I'd like you to work on your homework. You should do exercises 177, 179 through 80, and you should read exercise 178. Have a great day.